Okay, so this is a video for book 10, pages 10 and 11, which we didn't cover in class. So page 10 says formulas involving square roots, and they're going to teach you two standard formulas that are used actually more often in science than in math. But these are standard formulas that you can use. You know, they didn't make them up. They're ones that have been around forever. So here we go. The first formula involves objects falling, and this is the formula. T equals 0.25 square root of d. And here's what these numbers mean. So t is the seconds that it will take the object to fall after it's dropped, assuming that there's no air resistance. And d is how many feet it's dropped. So for example, if I dropped this pen cap right now and I measured how far it was, let's say it's like, what is that, probably about 4 feet. I could put a 4 right here and I could do out this equation and I would find out how much time it's going to take for the pen cap to drop. So let's do a couple of examples, okay? The first one says, how long does it take a wrench dropped from a 30-foot roof to reach the ground? So we write the formula. The t is the seconds, the how long, the time. That's what we don't know. And then it's dropping 30 feet to the ground. So what we're going to do is this 30 is not a perfect square. We don't know what the answer is to that. So we're just going to pop that into the calculator. And does it tell us how far to round? It says round to the nearest tenth. So we're going to do 30 square root. I got 5.477. Remember that when things are next to each other in algebra, it means they're multiplied. So I'm going to round it to 5.5. And this is equal to t. So then I'll come down here and I'll just do the math. I'm going to put in 0.25 times 5.5, and I get 1.375, so I'm going to round that 1.4. So it will take 1.4 seconds for the wrench to hit the ground. Okay, let me give you one more. I'm going to keep the same formula up there. The next problem in the book says, if there was no air resistance, how long would it take an object to fall 1 mile? So again, they're asking us how long, that's the time that we don't know. And the distance is 1 mile, which is 5,280 feet. So I'm going to put that in my calculator. 5280 square root. I'm rounding to the tenth, so I got 72.7 times 0.25 equals t. So I'm just going to, again, calculator, 0.25 times 72.7, and I got 18.2. So we'll take 18.2 seconds for that object to fall to the ground. Okay, now I'm going to flip over to page 11, and they're giving you a different formula. It's a standard formula, been around forever, used all the time. And this formula has to do with how far you can see, assuming that it's clear. And so here's the formula. D is equal to the square root of 1.5h. Notice that the h is inside the square root. So d is the distance to the horizon, and h stands for the height of your eyes, the height of where you're looking. Okay? So the first question says, measure, estimate the height of your own eye to the nearest tenth of a foot. So I'm 5'8", so I'm just going to guess that my eye is probably 5'5". I don't know. I could measure it, but I'm just going to guess. So the distance is going to be equal to the square root of 1.5 times the height of my eye to the nearest tenth. So I'm going to call it, 5.1. I just made that up. Okay, so in the calculator, I'm going to do 1.5 times 5.1, and it equals 7.65, and then I'm going to push my little square root button. So D is equal to 2.8. Again, I'm rounding, and that's miles. So what that means is if I'm standing on the beach and it's a clear day, I can see 2.8 miles into the horizon. Okay, let's do one more of these. The second one on page 11 says, how far away would the horizon be if you were standing on top of an 80-foot tower? And then it says, remember to add the height of your eye to the tower's height. So the distance is what we're trying to find. Our height, I said before that my height was 5.1 feet, so we'll stick with that, plus the 80-foot tower. So it's going to be 85.1. Okay, so I'm just going to multiply 85.1 times 1.5, and rounding to the nearest tenth, I got 127.7. This is still inside the house. Then I do the square root. Whoops, hold on. 127.7 square root. I got 11.3. So in other words, if I'm standing at the top of an 80-foot tower, I can see the horizon that I see is 11.3 miles away. Easy peasy, right?